this morning, and before we get started, we're going to wait just a couple more minutes to allow everyone to have a chance to sign in here. Thank you for your patience. All right, looks like we are ready to begin. Hi everyone, and welcome to our webinar session today. My name is Andrew, and I'll be moderating and co-presenting this session. Our topic today is an overview of LIDAR processing in LP360, and my colleague Jordan and I will be taking you through this presentation of LP360. So before I hand this session on over to Jordan, I'd like to go over a couple things with you. Group audio has been disabled for this session. If you'd like to ask a question, please use the question box on the GoToWebinar panel. We will pause at certain points during the presentation to answer any questions, and this will be roughly a 60-minute session, so we'll have some time at the end for any additional questions. At this time, I'd like to go ahead and do an audio check. So if you'll notice, the raise your hand button has been circled in red on the slide. If you can hear me, go ahead and click this button now. All right. So this presentation will be an introduction to LIDAR using the LP360 extension for ArcGIS. During our walkthrough, we're going to demonstrate how LIDAR can be useful to your GIS workflow. We'll be looking at some LIDAR viewing options, including our 2D, 3D, and profile views. There will be demonstrations regarding hydrological uses, land uses, using our volumetric analysis, and then we'll also look at some classification as well. At the end of the webinar, we'll have a Q&A session, so as we go through here, please go ahead and send those questions in. So just a brief introduction of who we are. GeoQ started in 2003. Along the way, we became the North American reseller for TerraSolid products. In 2009, GeoQ acquired QCoherent Software, which is where LP360 comes in. It's a first-of-its-kind LIDAR software extension for the Esri ArcGIS environment. As an extension, it can work in ArcGIS, but it can also be used as a standalone version. So if you're evaluating right now, or if you decide to purchase, you have access to 3 versions. You've got the extension, a 32-bit and a 64-bit standalone version. These come as a node-locked or floating version. So at this point, I'm going to go ahead and turn things on over to Jordan, who's going to take a look at LIDAR and then take a look at some of our first demos today.
Thank you, Andrew, and good day, everybody. Thanks for stopping by and taking some time out of your busy schedules to watch our webinar. I'm going to go ahead and take control, and we're going to go over just a few things with you. So, most common question that we get here is, what is LIDAR? So, a brief definition would be LIDAR stands for light detection and ranging. And it's a remote sensing method that people use where light is in the form of a pulsed laser to measure ranges or variable distances to the Earth. And these light pulses combine with other data that are recorded by that same airborne system to generate precise 3D information about the shape of the Earth or the surface characteristics. So if you look at these pictures that I've got displayed on my PowerPoint presentation here, you can see that the point cloud being displayed in the images on the left here is the main window, and the right is the 3D window, and at the bottom are the profile windows that we use inside of LP360. So to further illustrate this point, we're going to go ahead and jump into a demo. And we are in Arc Map right now. And first things first, let's go ahead and import some data to work with. This is our I/O manager, or our import tool, where you can open as read-only, read-write. You can load files or footprints. And we're going to go ahead and add some files here. So there we go. We've added all of our LAS files, and the reason why we're using our I/O tool here with the red cross is because it will import all of these separate LAS files as one in the task manager in the main toolbar, as opposed to using the black cross within ArcGIS. That will import every LAS file in separately, so you'll have to go in and change settings for every single file that you're working with. And we've got all of the separate names laid out here on the left. We've got all the separate points for each file with a summary here at the bottom. So we're working with about 103 million points, and working with about 2.9 gigs altogether as well. I'm going to go ahead and import all of those. And we're going to go ahead and start over at the far side of the main LP360 toolbar here. The toolbars that we're going to be going over today, you can access by right-clicking at the top of this empty space here within the program. And this will reveal all of the LP360 toolbars. The ones we're going to be working with today are LP360, the main one, the QAQC, and the viewer integration toolbars. And this is the main one that we're working with. And here you can change your project settings, such as where you want your project path to be. So you can set that manually there. You can import ASCII or NG4 files from that tab as well. You can access the manual or the help menu. And you can check about the LP360 program, what version you're running, how many days you have left on your license. And you can also check for updates, and it'll go to whatever your preferred web browser is and make sure that you're running the latest software. And this is your layer control, so you can decide which layer you're wanting to work with if you have multiple ones imported. We've also got the number of points that are currently being shown in the data set. So we're seeing about 201,000, and that's only about 0.2% of our data set right now. So it's a very small percentage of it. We're going to zoom in a little bit, and we're at about 7.69% now, and we're going to want to be a little bit closer. So at about this range, it's a good time to force 100% resolution, and you can do that using this triangle button. And this will force all of the points to show that are currently on that screen to give you a lot more detail to work with. And for purposes today, we're going to switch to 10 mode. It'll give us a little bit better visualization of our data set here, just so you can tell how much denser the data set gets when you force 100% resolution. And we'll go ahead and disable that. And we're going to come back to the export tool there, skip that for now, and go to the LAS layer properties. And the LAS layer properties gives you access to tools, general settings, source symbology, where you can change coloring, display functions for things that you have classified in the environment, filters, break line enforcement, return combinations, a lot of different things that you can do within the display toolbar. And you've got your performance settings as well within the LAS layer properties. We already went over the import tool, so we're going to skip that for now and talk about the display types. And as I said before, we will be drawing in 10 for most of these examples, just to give us a more visually appealing data set to work with. Okay. So the first things first, we're going to go over the type of display that we're doing right now is elevation. And elevation is pretty self-explanatory. The high points that we're seeing right now are represented by the red coloring, and the lower points are represented by green or blue, which can be attributed to either ground points or water points. And next up, you can display by color band. And color band is great for working with elevation data. All of the bands of color that you're seeing here represent a different or their own elevation value. So they're kind of like contours in a sense. And next up was going to be display by classification. And if I had anything classified right now, we can zoom out a little bit and see in this area you've got a little red. So I've classified that entire set of buildings. And you can see some surrounding buildings are still left unclassified. So that's the difference, is you're able to go in and automatically or manually classify depending on what license type you have. And next up, we've got intensity. We've got the display by intensity, or we can just apply intensity to any type of display that we're using. So for example, this is intensity here, and intensity is similar to an orthophoto, so it can be a huge advantage for people who are in a hydrological setting or emergency management fields, because it has a really useful heads-up display and digitizing of brake lines, rivers, and roads. So objects such as metal roofs will have a stronger return than asphalt, but it's not exactly an infrared image, but it can help you interpret and classify those points without having to create a surface model. And moving on from that, we got display by return combination. And return combination is basically showing you multiple returns are created when a single pulse is omitted and backscatter is detected by the sensor. The magenta coloring here represents the single returns, and the more colorful areas like the green and blue along the shoreline or patches up here represents the areas of multiple returns that I have mentioned earlier. So you can guess that the backscatter is that of vegetations, buildings, the shorelines. And we can do a profile combination view here. I'll just draw a line just so you can see what return combination looks like in the profile view. And next up, we are going to go to point source. And what point source does is it shows you different flight lines in your data set, so you can see if there's any overlapping data. And in order to best view this, we are going to want to go back to drawing points. And that way you can see all of the flight lines and without any obtrusions or anything like that. This will also affect the visualization and the accuracy of your data set, so you can see how dense it is. We'll go back to 10 for now. And next up is something that we don't have in this data set, but if you're working with SGM data, displaying it by RGB values is pretty valuable, and there's a display type for that as well. We're going to skip point files for now for time's sake and go to elevation difference. And elevation difference is great for use in QC because it's going to give you the ability to visualize the vertical deviation of flight lines from one another in the data set. And it's best seen difference-wise by zooming into water and seeing the lines that differentiate it from the land. And next up is point density. Point density is going to give you the ability to visualize the point density within the data set. And in order to best visualize this, we're going to go into the last layer properties here and go into symbology and change the intervals from 4 to 8. And this will give us a little bit more to work with here. You can see the patches of yellow just started to appear. And both the elevation difference and point density display modes are going to be awesome for when you're wanting to do a quick close-in inspection of your data. So if you're wanting to have a more concise analysis of the data set, you're going to want to create a surface product in our export wizard using the point insertion method. And next up, we are going to go back to elevation, and I'm going to show you what this filter does over here. We're going to filter out only the ground points. That's all we want to see right now. And turn on contours. And there we go. We have our visual contours over the image. And we can go back and show all points again. And it's pretty quick and straightforward. Very simple to do. And you can also, just for kicks, draw points on a 10. That's just another way to view a 10 model there. And so that's pretty much the main LP360 toolbar in a nutshell. The only other thing I left out was exporting, and all you have to do here, it's a simple, easy 3-step process. You can do a point product, a surface product. You can filter out those points that you want to export. And so let's say I just want to export everything from an area. That's fine with me. You can export it in 10 or another couple of options there. You can auto-compute the cell size, enforce break lines if you have them imported, multiple surface attributes to select if you want to export those, and export formats. And you can actually save those settings if you want to keep them. Also, second step of the export wizard, you can define what area you want to export out. So many different areas. I just want to draw a small window here. Just this area. That's all we want to export. You can apply buffers or cookie cut that area as well. Once you're done selecting that, all you have to do is select a file, and that's what I exported earlier. And all you have to do there is click Finish, and it'll automatically export that and show it inside of the program. But all we have to do here is go in and add that. Oops, clicked the wrong one there. And it'll import it in. But for time's sake, we're just going to skip on to the next toolbar. And the next up, we're going to view the LP360 Viewer Integration toolbar. And we're going to pop the profile window on that we're working with. And here, we have access to many similar features that we do in the main window. And the same goes for the 3D once we start talking about that. You can change all of your display types. It has everything that the main window does with an addition of GIS Fusion. And GIS Fusion is something that we're going to go over at the 3D window because it's a little bit more easier to see and understand in the 3D window than it is here in the profile view. You also have access to tools such as zoom and panning throughout the area that you have scanned. And you can also measure say you want to see what the height is of your tallest building in an area or tallest tree. And you can access, so that distance is about 22.6 meters, and you can see that number right down there. And you can do display properties just as you can in the main window, profile depth, profile export settings. You can filter out only the points that you want to see, just like you can in the main window. You also have access to manual classification inside of the profile view. So you can classify points above or below lines. You can access paintbrushes, and this allows you to select your source points of what you want to classify, and then you choose what you want to classify that area as using that tab. And that's pretty much the profile window. Next up, we're just going to draw a 3D window here in the same area. So we're going to zoom in a little bit, and you can see everything that I do in the profile view reflects in the main window and in the 3D window. So that's really useful in making sure that everything is staying the same and all the things that you're doing reflect in the other windows. In the 3D window, as I said before about the profile view, shares a lot of the same display types, and the only other thing that it does is the GIS Fusion. And with that, we will just import an orthophoto, and that we can define here by going to display properties and going into GIS Fusion and choosing the ortho. And it turns into a hybrid image of the point cloud mixed with your orthophoto. So very useful, very speedy too. So there's no lag or any hint of a slower computer performance, but you're being able to visualize all your points combined with the imagery as well. And so that's pretty much everything about the 3D windows and profile windows. You can also access a line of sight tool as well, and we just want to let's draw that line of sight here, and there we go. It pops up in our profile and our 3D view, and we can snap to it as well, and it'll go right to it in the 3D view. We can zoom in and out, and it'll show you the flight path in the main window, and you can click the right button on the mouse and zoom all around it, all around your point of origin, that is. And this line of sight tool is really good for people that want to see obstructions between 2 points in their data set. Make sure nothing's in the way in that area. So that's the line of sight. And next up, we're going to go on to our QA/QC toolbar. And it shares a lot of the same features, such as drawing a profile line in 3D windows. You can also do jump extents. So you can jump whatever percentage that you have selected in here within the data set that you're working with. And that goes all the way up to 100%. So that's if you want to quickly go around the data set and make sure everything is as it should be. And we'll skip those for now. You can also toggle hill shading. You have seam line analysis functionality as well within the QA/QC toolbar. And you can create a QA/QC feature class as well. But those are the main features of those 3 toolbars, and we're going to go ahead and hand it back over to Andrew, who's going to go over a few more features with you.
All right, thanks, Jordan. All right, so before we look at some additional demos, I'll give Jordan a chance to catch his breath here. I wanted to briefly discuss the next software level. So we're going to move to our standard license level. And with standard, you gain more analysis tools as well as some additional processing tools. So you have the ability to do manual classification, ability to go in and create break lines and use the conflation task to enforce those. And you also gain all the abilities of BASIC as well. And we've recently added some new tools right at the first of the year, and one of those was our volumetric analysis tools. And we should be looking at a new update with a new release here sometime around the 1st of July. So we'll be getting ready to do a presentation on some of the new tools we'll be incorporating here within the next month or so. So we're going to take a look at these volumetric analysis tools. And like I said, this is one of the biggest tools from our recent release, 2013.2. So if you're evaluating it at this point, you should have access to these. And this gives you the ability to digitize surfaces and compute volumetric information directly from your point cloud. So we're going to jump right into a demo of this. And the biggest immediate use for this could be stockpiles and mine volume computations. But these tools will work anywhere you want to determine that volume. And since we initially released these tools, we had several different default macros of these, but we've released two new ones. We have one for digitized input and one using a shapefile. So these kind of streamlined the process and made it a real point-and-click type of operation, where the shapefile is that would be if you had a pre-existing shapefile for these areas of interest, or the digitized input allows you to go in and create one of those. So I'm going to kind of demonstrate just this digitized input so you guys can get an idea of how this actually works. With these, you can go in and select your conflation task or how you want to create your z-values for that. And then it selects a output path. Inside of that, we're going to create a few products. So the first of these will be a volume attribute table. We'll do a cut fill TIFF image, and then we have an option to do a brand new LAS file just for that area of interest. So with that in mind, I want to use our point cloud tasks execute toolbar. So with this, I'm just going to trace a polygon around this pit mine we have. And in the bottom left-hand corner here, we can see which product it's working on as it's processing. So this is a pretty quick task for this area. So if we go in here, I'm going to turn off the original LAS layer. So this is that cut and fill image where the magenta represents the fill area, the light blue color would represent the area that's being cut away, and then you'll see these areas of white in between. So these are areas that wouldn't have had any change in your elevation. This is the shapefile that's created. So if we open this up and take a look at our attribute table, we can see some of the volume information in here. So we can see that cut and fill, and we can see that the volume of that mine is just over 7 million cubic meters for this particular area. But then you get some additional information such as the perimeter of your area and some of the z-values associated with that. And then that final product we created was the brand new LAS file. And when I did this, I did it based solely on those ground points. So we can take that, pull that up in our 3D, and we're only going to be looking at those points of interest. So now you can have a new LAS file of your mine, of your stockpile. And one of the big advantages we see of this is going to be paired with the emerging UAS industry, where you can go in and collect this data more frequently. And with that in mind, we'll kind of show you the link for that a little bit later. But in the late next month, we're going to be doing a webinar solely on kind of UAS industry and how that's going to end up being paired with LIDAR and point cloud collection. So I'm going to go ahead and turn it back over to Jordan. We're going to take a look at some of our hydro modeling tools.
Thank you, Andrew. All right, let's go ahead and move into this. So what we're going to look at right now is break lines, how to convert a 2D into a 3D break line, and also how to enforce break lines. So I've got my 2D break lines imported, and I've got the break line of the water bodies here imported as well, and that's going to be something that we're going to want to enforce because a lot of the points are kind of going into the water and whatnot. So we'll straighten that out here in a second. Let's go ahead and convert these 2D break lines over. We'll disable the body of water there. Just to show you that these are 2D, we're just going to click and show the properties here. So you can see it's only got X and Y values, so it's lacking that Z value that will make it 3D. So let's stop editing here. And we will need the LP360 classify toolbar for this function here. And what we can do is go into the elevation conflation / classify. And it's already got our 2D break line selected. And all of these features are as they should be. We're just going to put the classification as reserved there. And yep, everything's good. And we'll choose the ally. Export file is just test. And that should be it. We have to just conflate it. Only takes a second to get those Z values. And we just got to import that in now. So test 2, that's what I just exported out. Now we'll disable that 2D break line. And these are our new 3D break lines. So let's go back into the editor. We'll start editing and we'll select test 2. Now when I go to properties, we've got a brand new set of Z values there. So it has now been conflated and turned into a 3D break line from just a regular 2D. So that's that. And next we're going to look at how to enforce a break line. So let's go ahead and enable our map. And we'll zoom in here a little bit. And let's go ahead and turn on our contours here. You can see all the contours are coming into the water, and they're not conforming to the banks like they should be. So if I turn on my wireframe, it's in the same window that you have the draw 10. I'm going to just draw it in wireframe. You can see all of those lines are kind of out of whack and they need to be enforced for it to recognize that break line. So let's disable the contours right now. And next, what we're going to want to do is go up here to the layer properties, and we want to go to display and break line enforcement. And we want to enforce that map that we have. We'll go to mean Z, which is the average of the Z values, and we'll modify classes to water and rail. And before I hit apply, I want you to see how kind of out of whack these lines are. And as soon as I hit apply, everything conforms and recognizes that break line. So just again, those are the differences in the quality of the break line tool. It starts conforming to the banks. So that's how you do it in the main window. We're going to go ahead and zoom out a little bit. And I'm going to show you how it looks in the 3D view here. So there is my 3D view of part of my break line. Let's show contours in here. So you can see, just as before, all of the contours are out of whack and they're leaking into the water. So we just got to go to the display properties inside of the 3D window and go back to display just as we did in the main window. And break line enforcement. So check that use break line enforcement. And we'll go to mean sea again. And water and rail. And that's it. And so once you apply that, you can see all the contours are cleaned up immediately, and it recognizes the break line. And if you go in here and you click Control and you scroll with your mouse, you can toggle the vertical scale. You can increase it just to show you how the data set looks when it's got a cleaned up break line. And you can visualize those lines a little bit better. And so that's what it looks like with an enforced break line, and as it should look like. And with that, I'm going to go ahead and hand it back over on to Andrew.
All right, thanks, Jordan. We're going to go ahead and move on to the final license level inside of LP360 and take a look at our advanced features. And our advanced license level is the home of all of our automatic tasks, so the ability to automatically classify ground and buildings, as well as some other features such as those, and then also the creation of building footprints, vegetation footprints. We have some automatic processes for those as well. So to kind of demonstrate these, we're going to take a look at an unclassified data set, so you can see in the corner what a finished product could look like. So we're going to make this largely unclassified area kind of turn into that type of look. So with this, you can access these through the point cloud task icon, and you can create. We also have some that are already pre-created in the evaluation. So you can come in here and take a look at these. So here's that ground classification. Planar point filters for buildings. We have model key points. So we have several different ones that you can go in here and look at, and you might see some that you don't have in your evaluation. So some of these, will, again, are the ones we're going to take a look at in our new release coming up in about a month. So to start off with, I've created a macro, and in my macro I've set it up where I can take a look at my low points, pull those out, and then go in and classify my ground filter. And you can see in each of these filters, they all have their own set of parameters that you can work with and edit. And this allows you to set up the best filter for your particular data set based on the characteristics of that data set. So we're going to be using the same set of point cloud execution tasks as we used on the volumetrics. So with this, I'm just going to draw an area around the subdivision. So what we're doing right now is classifying those low points, and then we should have a really well classified ground class. So we go in and take a little bit closer look at what we're working with here. So it looks like we had a pretty good ground classification on this area. One thing you can do to kind of spot check that is draw a profile line. So we can see here that we have a good ground classification, and all of our above ground features have remained unclassified. So as we scroll through this, we can see that stays the norm here. So we know that we've got a good set of parameters on our ground. Now the next step I want to take a look at is going in and doing our buildings. And with that, again, I've set up a macro. And what this one will do is allow me to classify those buildings and then create those footprints for those buildings. And you can see again that we have several sets of parameters here. So I'll take a look at our preview window, and this allows you to check out these parameters before you ever run them on your projects. This can help you save some time. And so what this allows you to do is you can go in and change these parameters and see if this affects the outcome before you actually go in and run that. So we can see a little bit of a change here. So I'm going to go ahead and run this on this area here. And this will create two different shape files for us. So the first one we're looking at is the actual outline of those building points. And this is what we call overlapping polygons. And this is typically good for using on vegetation, so you can use these same filters on different areas. So we can see how it's actually sticking to the outline of those points. Now our second one is a squared footprint, and this is an estimated outline of the buildings. So we can see that we're picking up these squared features, that we're getting good outlines on these buildings, and just representing a squared feature that we'd expect to see along with our buildings. Now those are the advanced features, but I want to kind of mix it up. We're going to go take a look at back at our standard license level, and we have some manual classification tools, and this can come in handy for doing some of this cleanup once you've done automated tasks, or if you've already got classified data where you can come in and kind of edit that a little bit. So one of the things we can kind of pair this with is another option on our QC toolbar. So I want to set up a new shapefile, and this will allow me to go in and select areas that have been incorrectly classified. So I can take a look and draw a polygon around this, and then we have some issues that we can set up. So we can say we have a classification error on this building. We can make some notes. And while you're doing your QC process, that you can then go in and log all of these. So once you've done that whole process, you can then come back through, open up your attribute table, so you can see when it was created, who created this error, and then maybe what you need to be looking for that you may not be seeing. So once you've done that process, then we can go in and do that manual cleanup on this area. So we have two different ways that we can use these classification tools. We can do it in the main window, or we can also do that in our profile window. So I'm going to set up the manual inside of the main window, and we have this filter that you've seen throughout, and how I want to set this up is just to eliminate points I don't want to change, and then I want to move these points to our building class. So using one of the paintbrush options, I can just simply highlight these points and then quickly move those back to the correct class to finish up that correct classification. So if we go to another area here, we'll take a look at that same process in the profile window. So we can see we have these unclassified points. I'm going to set this up the exact same way, where I'm just working with these unclassified points. And then these brushes work a little bit different. Instead of painting each individual point, we can do an option where we classify everything above a line. So it helps if I set it up correctly. So as I draw under this, we can see that we're highlighting these points, and then we can automatically classify those, and you can see that change in the top view. But by eliminating my ground points, that means I can draw my line under the entire area and just change the building points. So this is a couple different ways to do that manual cleanup once you've gone through and done the, I guess you could say, heavy lifting with the automatic tasks. Now we have some other semi-automatic classification. So if you're interested in doing your vegetation, we have an option to set up a height filter. And on this height filter, it's simply going to classify everything above your ground based on these different parameters. So you can come in and edit these. So with this one, I'm going to make everything between 0 and 5 meters my low vegetation. So now that we've done that, we can go in, look at our profile, see if we see any different heights in here. So about right here you can see where that color change is. So that's where we go from our low to our medium vegetation. So this is just a quick way to classify everything above ground after you've done your buildings that you're going to possibly assume as vegetation. And then once you've done that, you can apply the same kind of extractor to the vegetation to create polygons for your vegetated areas. And then to take a look at our last classification filter, we have a basic filter that we can set up. And so this one can be used to move points from one class to another, remove points based on elevation, other features like that. So you could remove elevation. You could work with just simple ranges of intensity. And how I have this one set up is I want to go back and clean this area up and unclassify this area. So I'll simply run it over that area and we'll unclassify all those points that I've just classified. So it's just a way to move classes back and forth from one to another. And that's our basic filter. And that, again, is in our standard level. So I'm going to go ahead and turn things back over to Jordan, see if we've gotten any questions. Go ahead and send those in. And we're also going to take a look at some upcoming events.
Thank you, Andrew. And as Andrew pointed out, if you have any questions, please feel free to type them into the question box on your GoToWebinar panel. Also, I wanted to show you our contact information here. Let me take control again. Okay. So once again, I'm Jordan, and I'm the international guy. If you ever need anything outside of the continental U.S. and Mexico, or Canada and Australia as well. Andrew's just taken over those territories. And Kayla will be Eastern U.S. and Canada, and Andrew is going to be Western U.S., Mexico, Canada, and Australia and New Zealand. And let's see, we got a question, it looks like. And Andrew, can you export the cleaned up contours?
You can export out the contours. You can export out contours, or you can clean up. Basically, you can add in your break lines into your exported surfaces to create a DTM, and that will help you clean up those contours as well, if that's what the question is referring to.
I believe so. And next up, let's go ahead and pull up our website here. And this is the main LP360 website. It can be found at qcoherent.com. And here is where you can access a free evaluation of the software. If you or anyone you know would benefit from LIDAR processing, please feel free to download the LP360 evaluation. You get a free 30-day trial. And we also give you access to free LIDAR data just to kind of solidify the need or the importance of working with a good data set. And also you can access our webinar schedule and our next events webinar-wise that are coming up. We've got one next week, which is June 18th, and that is our volumetric analysis from point clouds webinar. And we'll also have 2 of those as well that day. And after that, on June 26th, we have got a conversation with the National Geodetic Survey as well. So come for that. That'll definitely be a very interesting webinar. And then about a little over a month later, we're going to do our first webinar. Again, the same one we did today, an overview of LIDAR processing inside of LP360. So there's going to be a period of time when we don't do anything. We got a busy month in July, which brings me to my next point, upcoming events. The next time you will see us will be in San Diego at the Esri User Conference. Definitely stop by and say hi. Both Andrew and I, who have been doing the presentation today, will be there. That's July 14th through the 18th. All week we'll have a booth set up, and eager to meet all you folks. So if you're in the area, please stop by and say hi. Next time after that, we'll be in Louisville, and that is September 15th through the 17th. And that's the Kentucky GIS Conference. And then GECO in the Rockies in Grand Junction, Colorado, from the 22nd to the 26th of September. And we've also got our, I think I clicked something, our LP360 training event, which we highly recommend if you want to use the software and want to know all the ins and outs. We can only cover so much in a webinar every time we do it. And even then, there are some things that we leave out. And that really opens the door for people to sign up for our LP360 training event. And this year, it is the 23rd to the 25th of September. And that's going to be at our home base of operations in Huntsville, Alabama. And you can go click registration now, open, and it will give you all the details. And you can sign up for it there. So we would really be happy to see you here if you're wanting some in-depth training that is usually a lot cheaper than bringing one of us out or flying here alone for training. And it gives you so much information about the software, and you will definitely leave the training 100% confident that you know all the ins and outs. And it is a very useful couple of days. So definitely consider that. And pretty much covers our website for today's webinar. So if you have any more questions, once again, feel free to type them in the question box for us. Andrew, if you want to add anything else, please feel free to do so.
Yeah, he mentioned we have the volumetric webinar next week. Over the last couple months, we've gone through and done more specific webinars on classification. We spent a full hour on that. We spent a full hour on our break lines. So if there are other features that we kind of touched on today that you'd like a little bit more information on, we definitely can provide those recorded webinars or some other documentation as well.
All right, if no one has any further questions, we appreciate you guys coming out today, and I know how busy days can get and how hard it can be to sometimes eke out an hour to designate, but we really appreciate that. And if you have any questions, once again, please let us know. And I'll leave the webinar open for a couple more minutes just in case someone has another question.